Okay, hello, my name is Pavel Filipenský, and I would like to present about new keytab generation. Something about me: I work for Red Hat. I'm Samba maintainer since 2021, and I'm also Samba team member since 2022. So first, just simple introduction. What is a keytab? It's a short name for a key table, and it stores long-term keys for one or more principles. And there we can see one example, which was produced by the klist command. And it shows us that each entry consists of key version number, that's 1 in this case. Then we can see also the timestamp where the entry was created in the keytab. We see principal name, the encryption type, and at the end there is the key itself. Explanation, for example, how Samba can use keytabs. So when SMB client tries to access Samba file share, then of course it starts first with the TGT, which it gets from KDC. Then it's asked for the service ticket for the SIFS service. And that's both transactions are done with KDC, and then the client connects to Samba server and sends the service ticket. And at that point, the Samba needs to decrypt and verify the ticket. And it can use the keytab, or it also can use secrets-TDB, which is also storing the keys. So this is the place where Samba is using the keytab. I will now mention the existing smb.conf parameters which are related to this topic. First of them is Kerberos method, and it says how Samba file server should be verifying the tickets. And the default method is the first one, secrets only. It means that Samba is not using the keytab, but it looks to the secrets-TDB. Then we have a combination. Then we have a system keytab. That's the other option. In this case, secrets-TDB is not used, just the system keytab. Or we can use a dedicated keytab, which is a keytab on a different place in the file system. And the last option is the combination of the two. We can use secrets-TDB and the system keytab. This parameter in the future will be changed. Andreas told me that for their local KDC work, they will need to verify against a list of keytabs. So the parameters will be slightly different. But it will be still the same principle. It will be either secrets only or secrets and combination of multiple keytabs. Then we have also parameter dedicated keytab file. That's just the path name that is used in case that the secrets that the Kerberos method is using dedicated keytab. Another parameter which exists is the machine password timeout, and it just says how often Winbind should update the password. The default value is 1 week. What is not documented, the machine password update happens only if we use secrets only option in the Kerberos method. So how my work on this topic started? There was Bugzilla from already 2009, and the synopsis says that after machine password timeout, the keytab is not updated. I have copied from the Bugzilla report 3 paragraphs which nicely state the goals of this work. The one says that Samba knows how to update the password. Knows how to update the machine password at DC, but it doesn't update the keytab. And when this happens, all the Kerberos services are broken because they don't have a recent password or the keys based on the recent machine password. Other thing what was in this Bugzilla is regarding the content of the keytab. It says that a better job is needed than NetADS keytab create is doing because the entries do not contain any additional SPNs which were added before. So it's about the content of the keytab. And the last paragraph mentions that there is no way how to handle multiple keytabs. For example, the user wanted to have a separate keytab for his web server. So till this solution was available, typically these typical workarounds were used. It was possible to set machine password timeout to 0. It means Winbind is just not doing the update, so nothing is updated and nothing is broken. Another approach doing the same is setting the Kerberos method to something else than secrets only, because in this case also the machine password is not updated. And one of the last and more sophisticated methods was to run always NetADS keytab create after the password was updated. But the hard task was to find out when this should be done, because the password update will happen somewhere in the future, typically in 1 week intervals. So there was a documented approach how to read, for example, from secrets TDB the attribute machine last change time. Then you add to it the timeout, and after that you will update it. And now to the solution which I have implemented. It's done via new smb.conf option. It's called sync machine password to keytab. I have a lot of discussions with Metze and Andreas about that. Actually, the values were mostly proposed by Metze. Thank you for that. There is example how the value can look like. We can see that in this case we will create 3 keytabs. Each entry starts with the path to the keytab, it's absolute path. Then we use colon to separate the parameters which are provided. There are 2 kinds of parameters. First is called SPN specifier. It says what kind of SPN there should be. So we see, for example, account name. That's the machine $ SPN. Then there is option sync UPN. It means sync prefix nominal read the value from the DC. In this case, it will read the UPN attribute from the DC and create SPN from, or create a principal out of it. Then it says sync SPNs. It means talk to DC and get all the service principal names and create principals. The other parameter is option. It no longer specify the principles, but it says what else should be done. I will mention it later. So the generic syntax looks like this. We can have a list of SPN specifiers, so you can have more. It's the plus which says it. Then we can have option sync etype, sync AVNO, NetBIOS aliases, additional DNS host names. And at the end, it's not visible, but it's a machine password. This is the complete list of the SPN specifiers. There are 6 of them. The first 2 are the same one, just the account name is created locally. The sync account name is the machine account name taken from the DC. Then we have this UPN, sync UPN, sync SPNs, which reads from the DC the user principal name and the service principal names. Then we can locally define principals using a prefix. For example, it's visible on the second line in the example. We use SPN prefixes IMAP and SMTP. And the last option allows you to specify the full SPN. That's the last example, the line number 3. Now this is the list of the options we can use. First option is sync etypes, and it means talk to DC, find the supported encryption types attribute, and there will be a list of them. Then take the information from the Kerberos library and use the highest common encryption type. If this will be missing, this option, it means that we will generate keys for all supported key types, which is the RC4 at the moment, AES 128 and 256. Another option is sync KVNO. That's the version number. That's the number of the machine password key on the DC, and with every change of the password, it is incremented by 1. But these numbers are in general not reliable, because if we have multiple DCs, it's known that it can happen that they are not really synchronized, that for the same password, different DCs have different version numbers. So it's common to ignore the version number during the ticket verification. So it's not necessary to sync the KVNOs and just use the -1, for example, for the current password. That's the common thing. Other option is called NetBIOS aliases. This is used only for SPN prefixes. And normally the keytab code would generate just 2 prefixes. One is with the NetBIOS name and the other is with the DNS host name. But we can also generate not just one NetBIOS alias, but not just one NetBIOS name, but also the aliases, and also not just one DNS host name, but also additional DNS host names. These aliases and additional host names must be configured in smb.conf. The last option is machine password, and it's kind of a mandatory option. And the meaning is that the key is generated out of the machine password. In the future, it can be extended. For example, we can have something like GMSA password, and it will be created for keys based on the group managed service account password, which is some concept which separates each services, that they use their own secrets, and yeah. The previous smb.conf parameter was a result of the requirements from that bug, but there was one more requirement. Actually, the requirement came from the previous sambaXP conference, from the keys, which is thank you keys for that. And there was a proposal that whenever we update the password, we have option for some trigger that will execute external code, some script. So the solution is the new smb.conf parameter sync machine password script, and the script will be called when the password is basically updated. Actually, we call it twice because when we update the password at the DC, we synchronize the keytab twice. It has two phases. The preparation phase, when we prepare the request for changing the password, and we never know how it will continue, if the request will be processed or not, if it will be lost or not. So already at the moment when we prepare the request, we are able to verify against the future password. So we update the keytab already before we get the response from the DC. But if we are successful and get the response from the DC, we update the keytab again, and we call this script again. So the script is normally called twice during the password update. Yeah, and I will talk later on this parameter again, because surprisingly it was not helpful only for some external cases, but also for clustered Samba. Now I would like to mention the principles which are used by default in keytab. With Samba 4.20, that's the Samba without this change, we typically have these SPNs in the keytab. You can see on the first line there is the computer machine with $ at the end. Then we have two host principles and two restricted kerb host principles, one with the NetBIOS name, the other with the DNS host name. Look that all of the host and restricted kerb host are in lowercase. Actually, how they got there, during the join Winbind, not the Winbind, sorry, the Samba and net-ads join command creates at DC some principles. And they are created actually in uppercase, but the current code was changing them to the lowercase when creating the keytab. With Samba 4.21, the default keytab looks a little bit different. You can see that we do not lowercase the SPNs, and the host is completely uppercase. Restricted host, kerb host has some capitals in the names, and this no longer works, for example, for the SSH service. SSHD is using the host SPN, but it must be in lowercase. So once I have implemented this, and the correct thing is not to change the case. In general, if some SPNs are defined at DC, we shoot them exactly as they are there. So I had to add the last two lines here. You don't see it? Okay. So the two bottom lines, there are two more host principles which are added extra to the new keytab, just to support the SSHD, for example. Yeah, some implementation details. In secretDB and also in keytab, we store 3, sometimes 4 passwords. We store the current password, the older password, and the next password. If we do not synchronize the version numbers, we use -1 for password, -2 for old, -3 for older, and the next password has VNO -4. Yeah, this I already mentioned, that if we update the password, the keytab is synchronized twice, during the prepare and during the finish phase. And when we are updating the keytab, we always want to make a functional keytab, so we never delete the complete keytab and put all new entries, but we start with adding new entries, and once they are there, we delete the entries which are no longer needed. For example, all the password will be now too old and will be removed. So the steps are for the case that we do not synchronize VNOs. We copy VNOs -1, -2 till -4 to -11, -12, 13, and -14. Then we remove the previous one, add new entries for -1, -2, -3, -4, and finally we remove this -11 till -14. I have also added traces to be sure that everything functions as is expected. These traces, they also show the content of the keys, so it's in general a secret which should not be in the logs, but this won't be there because this is only for the developer build available. And it actually traces all the manipulation of the keytab on the just before we call the libchar5 functions, and the operation is in the second column. Next operation, it means we are just reading the keytab, so we want to see the content. So for example, during this update, we have found out there are entries with VNOs -1, -2, -3. Then there is the add operation. That means we are now adding the -11 and so on. Then we remove and add and remove again, exactly as it was in the previous slide. These are the traces from the first phase, the prepare phase. So we see that after this there will be also for a while -4 in the keytab, VNO -4. But once we will get the response, we do similar things, but the -4 is deleted, and because it's the next password, and it's no longer the next password, now it's what's promoted to the current password. So finally there will be only 3 entries, -1, -2, -3. There is some overview of commands that can trigger the password update. First of them is Winbind doing the regular update based on the machine password timeout value. Then we have two similar commands, netadc, rpc, change trust PV. This is way how to trigger the password change manually. The same is rpc client usage, and the last one is the wbinfo change secret command. This is overview of operations that recreate or generate the keytab. Netads join is one of them. When we join the domain, we create the initial keytab. Then there is this netads keytab create. That's the way how the keytab can be recreated. And the last one, that's a special thing. If you will go to the man page, there will be a warning that you should do that only if you exactly know what is it. And this command, net change secret PV, with the force option, you must specify the force option, that changes the machine password only in secretsTDB, not in DC. That's typically used when something else is updating password at the DC. It's not the Samba, it's not the Winbind, but you want to have the current password in the secretsTDB. And that's newly, and after my change, this code also updates the keytab. Once I have done the initial work, I have realized that in the clustered Samba there are some changes necessary as well. If we have a cluster, only one Winbind process changes the password. On each node, there are many of them. They share the same smb.conf, so basically they roughly start to change the password at the same time, but in the code there is something that adds some random number of seconds, I think up to 10 seconds. So it happens that one of them is the first one that succeeds, the other check the time of the last change and see, okay, it was a change recently in the password, I will give up. And in the clustered Samba, the secretDB is synchronized automatically, so the new password is available to all nodes, but not the keytabs. Keytab was updated only on the node that triggered the change. So the man page says that in case on the clustered Samba, you should define the sync machine password script, that's the very line button, to the script which is called Winbind ctdd update.sh, and that makes sure that all other nodes will change it as well. And also the man page says that you should run command on node all ctdb event script enable legacy 46. I will talk about it on the next slide, what it does. Yeah. So this is the first script which should be run from the I go back from the sync machine password script option. So it means that once the keytab is updated on the main node or on the first node, not the main, it will run on no command on all connected nodes, and it says that the command is net ads keytab create, and careful. Now we set the option that the sync machine password script is empty, because otherwise we would create a kind of recursion, because the other nodes would, after they update their own keytabs, they would also try to run the script if it is defined, and that would again trigger update on all other nodes, and that would never end, would be kind of fork bomb or something like that. And second script just makes sure that if one node is recovered in the cluster, it will always make sure that it initializes the keytab again. So as we can see, the addition of this keytab update script make it quite easy to make the update working in the clustered environment. There was no other coding necessary, just to create these two small scripts. Yeah, and the code was released with the Samba 4.21, but soon some small or bigger issues showed up and were fixed later. This one was with free IPA and was fixed by Alexander. What happens? Free IPA is not using Winbind to update the password. It does it on its own. It also updates the keytab. And it just wants Samba to consume the keytab which FreeIPA maintains, so it defines Kerberos method dedicated keytab. And it calls this slightly dangerous command net change secret PV, because it wants to update the password in secretDB. But with my change, now this command triggers keytab update. And because no values were defined, the default was used, and the default content was to get the SPNs from DC, so it's trying to talk to DC. But Samba or the environment doesn't allow, there is no working connection to ODC, so it fails. So the complete command net change secret PV -f fails, and the whole free IPA scenario fails. So what was added? There was one more option that you can explicitly disable creation of the keytab. If this line was missing, the default value was used, but disabled means please no default, but do nothing. No update, please. And there was one more issue. And bug says that after net ADS join or keytab create, some services no longer works, and it was reported for SSHD, which was using host principle, and also for SSSD, which were using the computer dollar principle, the machine account name principle. And the reason was that the initial default value of the keytab didn't contain these two principles. It only synced the SPNs from DC, and as was mentioned before, the host principle was all in uppercase, which doesn't work for SSHD. So the solution was to change the default content of the keytab, and I have added the account name and SPN prefix with value host. This syntax was not allowed in the very first version. In the very first version, each keytab, we have many lines specifying many keytabs which owns paths, but any of them with the initial implementation could contain only one type of the specifier. Once you decide to sync SPNs, you cannot add prefix or account name. So it was allowed to combine them on one line, so each keytab can contain any SPNs. Yeah, and this is my last slide. So the presentation is finished, and there is a room for questions.
So I guess the keys and the keytabs, if you have multiple keytabs, are always the ones from the computer object, right?
Sorry, if the keys are?
So if you have multiple keytabs, all the keys in the keytabs will be the ones from the computer object and with the machine password.
Yeah, exactly.
So I guess currently having a separate keytab for Apache doesn't make much sense security-wise.
Exactly. That is the other option. There was this grouped managed service account that dealt with provider security. Yeah.
So
also, since all the keytabs or the keys are based on the machine password, and actually Samba, for example, is not checking the VNO and even the principal name. There is a just match based on the keys. They are maybe not necessarily, they are maybe too big, the keytabs for the Samba, but some applications which do not use GSS API but do direct Kerberos and libker5 interface, they can compare entries using the principal and VNO as well. So, yeah, but the answer is yeah, there is no extra security because the services can impersonate each other. All of them use the same keys.
And if there's no other questions, which Red Hat major releases is this in or will this be in? So I guess it's not going to be backported to 8, rel 8 or something?
No, it's only in rel 10 and in rel 9.6.
Okay, no more questions, I guess.
Okay. Okay, so thank you for your attention.